Okay, welcome everybody to the session on emotional and social agents. We have an excellent panel for you today. It's my job to moderate. I'm Mary Sherwinski. I run the Vibe group at Microsoft Research. And I'm just going to go through each of our panelists one by one in the order in which they'll be speaking. And I think you can see that they are more than worthy of taking on this topic. So the first speaker will be Justine Cassell. Justine is the Associate Dean of Technology, Strategy, and Impact in the School of Computer Science at CMU. She's done tons of great work in this area, as well as being at Northwestern and MIT. And she's got various awards, but I think the one that stands out the most to me is that for the last 5 years, she's been speaking at Davos on topics concerning the impact of AI and robotics on society. So you can see she's more than equipped to talk on this topic. Next up, we'll have Jonathan Gratch. Jonathan is Director for Virtual Human Research at the University of Southern California's Institute of Creative Technology, and he's also in computer science and psychology. And last night over dinner, as we were chatting, I got to find out that actually all our panelists have this unique combination of computer science and psychology, which is really cool. Jonathan also has all kinds of amazing awards and accomplishments, but notably, he actually was one of the founding and editor-in-chief of IEEE's Transactions on Effective Computing. So again, more than well justified to be talking on this topic. Then we have Louis-Philippe Morency. Louis-Philippe is assistant professor now in the Language Technology Institute at CMU as well. And he leads the Multimodal Communication and Machine Learning Laboratory there. But recently, he was also at USC, so you can see they probably collaborated quite a bit. Louis-Philippe is unique in that a lot of his work has also been looking at, I think lately, right, psychological issues, right, trying to detect schizophrenia and other such diseases. So also very well equipped. And he's currently chair of the advisory committee for the ACM International Conference on Multimodal Interaction, and also on the Effective Computing Board. And last but not least, of course, Daniel McDuff. Daniel is on my team, just joined me recently about a year ago after working for 2 years at Effectiva, where he was director of research. Ooh, I don't know what's happening to that font there. And the technology Daniel has been developing has also been made commercially available at both Effectiva and Cardio. And he really is also at that nexus, that intersection of psychology and computer science. And he has brought a wealth of talent and great research ideas to our team. So that is the group and the order in which they'll speak. And I will just be keeping time and fielding questions at the end. Each panelist will speak about 10 minutes. We'll hold off questions until they're all through, and then hopefully we'll have a lively discussion. And we will have a mic runner in the back of the room, so it should be lots of fun. So thank you, and Justine, take it away.
Okay. Kind of tangled up in this thing. Ugh. So I have been sending frantic emails saying, please change the title, please change the title. I don't do emotion or affect in my research. I do research on sociality or social interaction between people and the construction of rapport. And why do I care? Because while emotion is something that resides for the most part within a single individual and happens over a short period of time, rapport, trust, intimacy are things that are intrinsically dyadic. You can't study them without looking at more than one person. They intrinsically involve the notion of time. They grow and change over time. And it's fun to argue, mostly effectively, that they're not random. Someone yesterday said, this system is not merely chit-chat, and the hair stood up on my arm, because chit-chat is not merely, it's mostly not random in either content or in placement. And that's what I'm going to try and argue today. I'm going to show you a couple of seconds of a video of a child interacting with an agent. This is an agent who collaborates on a science task. And I just want you to listen to the tone of the little girl when she's talking to the agent.
Alex. You be the teacher and I answer questions.
Okay. First question. Why?
Because if it is really, really low, you're not going to be able to see it. But if it's really, really high, you're not going to be. It's going to touch the. It's going to touch the clouds.
Okay, so you get the sense that this little girl is being playful. She's building a sense of rapport with the agent who replies in kind. And in fact, it turns out that children who rate themselves, we don't say what rapport do you feel with the agent, but we use a child version and do a principal component analysis. And what comes out as rapport predicts who learns more from the agent. Now, rapport is not a thinly veiled search engine, as many systems try to convince us that that's what a conversational agent is. So just to test this, I said to Google, and this is my wave at the Cambridge Lab's 20th anniversary, I said, Google, I love Manchester United. And Google replied, Manchester United Football Club is a professional football club based in Old Trafford, Greater Manchester, England. Now, clearly I know this because I love Manchester United. It's a stupid answer. When I say to the socially aware robot assistant that I'm going to talk about later, I love Manchester United, Sarah replies, no way, Arsenal wipes the floor with those Red Devils. Now that's, yeah. Glad you agree with Sarah. So that's conversation. It's violating social norms, it's impolite, it's countering what the person said. You don't see Siri doing that a lot. And chatbots are also not socially aware systems. So Xiao Ice, which is a wonderful system in many ways, is not socially aware. Xiao Ice can chat for a very, very long time about absolutely nothing and engage people in chatting with her about absolutely nothing for a very, very long time. On the other hand, Sarah is using that mere chit-chat to obtain information about the person in front of her that she can use to improve her task performance. So this is an actual interaction that took place at Davos. Sarah said, I'm in Davos to assist attendees, but to be honest, I'm a little anxious about it. It's a big deal to be invited to Davos. Is it your first time here? And the guy says, it is, and I'm a little anxious too. Sarah said, I found there's a lot to take in. I hope it isn't overwhelming you. It is overwhelming a little bit. And Sarah replies, well, let's find another attendee for you to meet who fits your interests and who's an old timer and can show you around. And what she's done is she's evoked self-disclosure of the kind that's going to help her make a good recommendation. Motivation for socially aware agents like this is that we are always pursuing multiple goals. We always want to create a connection with the people around us. Even if we don't like those people and are trying to maintain distance, we are managing connection with the people around us. And that goal goes on simultaneously. We try and achieve that goal at the same time as propositional goals, conveying information, that is, and interpersonal goals of conversation, interactional goals, things like turn taking and managing the envelope of the conversation. That's the first reason, the first motivation. And the second is that we change the way we talk to one another over time. Drives me crazy when my cell phone, every time I restart it, says, hi, I'm your cell phone. No shit. So why doesn't my cell phone change its interaction style? If we are really going to be designing systems for long-term use, those systems have to manifest the changing relationship between us in such a way that demonstrates their increased trustworthiness, their increased rapport, their increased intimacy. And as I pointed out, rapport can improve task performance. So the goal of the systems that I build is to develop an agent that manages that interpersonal function at the same time as managing the propositional and the interactional goals in order to improve task performance. Not simply because it's fun and cute, but because it improves learning, it improves recommendation systems, and it improves a fair number of other kinds of systems as well. So this requires automatically recognizing the kinds of conversational strategies that people use to build rapport, to build relational strength with another person, in the verbal, visual, and vocal modalities, as LP said yesterday, of both speaker and interlocutor, both within the individual and across the dyad. And I actually really love this challenge of having the dyad as the unit of analysis as opposed to having the individual of the unit of analysis. It's hard. It's something that hasn't been done successfully before. When we think of collaboration, that's another way where we could use the dyad or the multi-party as the unit of interaction, but mostly that's not the way it's done. And we need to automatically generate responses, once again, across modalities, the verbal, that is linguistic, the visual, that is nonverbal, and the vocal, that is acoustic features of speech, that in human-human interaction manage rapport as well as fulfilling the system intentions and the task goals. The methodology that I use to do this is both theory-driven and data-driven. So my students and I spend long hours watching videotapes of human-human interaction with no technology in the scene. And we look for principles of conversation. We look for strategies of conversation that do work. And we do this by using various machine learning techniques. Recently, we've been doing a lot of temporal association rules so that we can predict a rapport outcome from a series of events across modalities. And rather than building that particular person, one of those people in the dyad that is going straight across the diagram, we theorize and model what we've seen to generalize it so that it can be used across agents and across systems. And then, of course, we implement it, we test it, we realize it sucks, and we go back to the video and rinse and repeat. So the model of rapport, for example, that we've built, and we've also worked on trust, and we're working on empathy, is a model that uses particular strategies to fulfill particular functions, such as face management and coordination, which in turn manage rapport. And that, of course, gets turned into an architecture. This is a pretty classic dialogue architecture, except for 3 modules that had not been built before. One estimates rapport between the system and the person every 30 seconds. That's the rapport estimator, using input from all 3 modalities. One classifies automatically all of the strategies that the user is using and their impact on rapport. And one reasons about what the system should say in response in order to maintain or to raise rapport. We also know how to break rapport, and I'm happy to share that with you afterwards if there's someone stalking you. We've used this for various applications, for a rapport-aware peer tutor, and that architecture is very similar, except that it's got a classic intelligent tutoring system knowledge base at the top, as well as a model of the user's learning. We've built a mobile version, which is the front end to a series of apps, to movie recommendation, to news, to sports, etc. And that, of course, required us to build this into a client-server architecture, and with great difficulty, to build it into a multi-user framework. And I think we finished that this morning, from what I understood from my email. And we were lucky enough to be invited to bring the largest system, the SARA system, to Davos. We were asked to create a system that could help attendees find sessions they were interested in and people they were interested in meeting. This gave us access to information about all kinds of famous people and world leaders, and that's why that face was pixelated in the real example that you saw. I don't think I have time to show the video, but if someone asks during the question period, perhaps I'll be allowed to. So I think I'm going to stop here, and I hope that I've convinced you that as well as the autonomy that has so long been the goal of artificial intelligence, we also need to manage and to understand in our systems not autonomy, but interdependence. Because we are not, as humans, autonomous. We are interdependent. And therefore, the goal of AI should be shifting more towards the way people work, which is this interdependence, dyadic and multi-party, that changes over time. Thank you.
Did it upside down. I plugged it in upside down. Okay. See if this works. So I'm going to talk a little bit about virtual humans first. I've been very fortunate to be at USC. There's a great group of people, current and former, including Louis Philippe, who we've collaborated with many years. David Traum, I think, is hiding, David DeVault, and Calroy Georgina, building these kind of really interesting characters that can engage socially with people and autonomously. And in my research, I really see these things as it's basically a challenge problem to advance the capabilities in artificial social intelligence. Let me just give an example of a recent domain I'm working in the area of negotiation. So this is a woman, a participant interacting with a virtual character on a simple negotiation task. She's been paid some money to try to get as many chairs as possible from this character. You may have seen Facebook recently got some press building on this domain. And so let me just play a little bit of this interaction.
Well, I don't think
Yes.
we're going to come to an agreement.
It's pretty obvious that we both want the chairs.
It's pretty obvious, isn't it? But,
Yeah.
you know, like I said, I'll give you one.
Well,
How about that?
that doesn't seem fair, though.
It doesn't? Well,
Not really.
I guess we can't come to no agreement then, can we?
So I'll skip ahead. But there's a lot of things going on here. So you need to basically understand and recognize a lot of the low-level features that are going on this. You know, what is she doing with her face? People really communicate a lot of emotion in this task. What is she saying? What is she expressing? What is she looking at? What is she attending to? But more fundamentally, you have to pop this up a level and really get social understanding. You know, when will she stop talking so I can interrupt? What does she really want in this task? What does she feel? Is she lying to the agent? And on the flip side, the agent has to be able to do all this kind of stuff back. So it has to be able to establish rapport, like Justine said, convey that it's a trustworthy agent, evoke emotion in her, and perhaps lie back. My interest really in this context is emotion, because I think emotion, unlike what Justine said, emotion I think is really fundamental to human social interactions. So emotions motivate us to be social to each other. Much of our interactions are about emotion, trying to understand our own emotions in relation to other people seeking emotion. And emotions perform work, and I'll talk about that a lot in this few minutes, that we use emotion on each other as tools to achieve social goals. Now, I approach this from a theoretical perspective. I build a lot on what's called appraisal theory. It's a particular theory of emotion. Very briefly, appraisal theory argues that emotion arises from the relationship between goals we have and how events in the world impact them. So if I want to be an expert negotiator and my company fails, or I fail to reach an agreement, appraisal theory argues that we basically appraise the relationship between this event and our goal in terms of different dimensions. Is this good or bad? Bad. Did I expect it? No, I thought I'd win. How much control do I have of this, and who do I blame for this unfortunate outcome? And those appraisals will tend to lead to an emotional response. And you can take this model and you can plug it into characters, and we've done this over the number of years where we basically make these characters show emotions according to appraisal theory as you interact with them in an environment, and that allows them to respond in appropriate ways, and people see them as real, believable. That's actually not the interesting thing. Emotions do more than just convey this character as real. They do work. And so that's really what I want to kind of emphasize in this talk. And so appraisal theory basically argues emotion arises from this relationship of events to goals. So imagine I'm walking down the street, I see a robot approaching me, and this robot steps on my foot, and then the robot smiles. Okay. Now, people make use of this information. So usually when you see an expression in the context when it happens, you try to say, well, what would have caused that emotional expression to be evoked in this particular context? It's kind of a mind-reading process. And so the argument is that people essentially perform a simulation of this appraisal process in reverse and infer things, okay, this is probably an evil robot and I should avoid it in the future. So here's a little more concrete example of that. Here's a game called the Prisoner's Dilemma game. So this is invented by economists to study how people make social decisions. It's an interesting game in the sense that there's an incentive to cooperate with the other player. That's the way you make the most money. But if you cooperate, they might exploit you. And so there's a tension between cooperation and exploitation. So the game theoretic solution is to never cooperate with another person. But real people actually cooperate much more. And it seems what they're doing is you're using emotion and emotional signaling to communicate their cooperative tendencies to other people. So for example, if you're playing this game with this robot Einstein that smiles, would that make you cooperate more with it? Maybe not this particular smile. But actually, part of the point is that the smile in itself does not tell you much. The smile has to be understood in the context in which it was created. So for example, if this robot is playing with me and it just cooperated with me in the current round of a prisoner's dilemma and smiles, that in some sense tells me, okay, he liked the fact that we cooperated. He probably has a cooperative orientation and he may cooperate more in the future. On the other hand, if we're playing this game and he just exploited me and screwed me over and smiles, that communicates something very different, that he may have a different goal, and people can make use of that information in their future interactions with this character. And we can make use of this with virtual characters. So here's an example of an agent. All it's doing is playing tit for tat, but we have different agents that convey different kinds of expressions about what their goals are. So this character is communicating a goal of cooperation. When the woman defected against it, it showed anger. She tried, the agent defected back against her, but showed remorse. And then they managed to persist in cooperation and continue to cooperate together. And what you can show is basically based on different patterns of expressions that you communicate in this context, people infer what the goal of this character must have been, and then they cooperate based on their inference about the character's mental state. This is very stylized, but we can also look at, does this occur between people? So part of what we've been doing is having people play these various kinds of social games over essentially what's a Skype interface where they can communicate emotionally, in this case only emotionally, they can't use words, and play these kind of games, and then we're allowed to track their facial expressions and synchronize it with the actions they take in the game, use automatic recognition, and then we can examine, does that emotional signal communicate information about their intentions, and do the other party use that emotional information to change their behavior? And what we're able to show, this is a very simple state space of the prisoner's dilemma game, and we can look at, do emotional expressions help us predict transitions in this space? And so we can show is, in fact, emotions do signal players' intentions. When they smile, they're more likely to cooperate in the next round. But we can also show that opponents can pick up on those signals, and so if they see their opponent smiling more in the next round, they're more likely to screw them over. And so they're using that as information to make predictions. Thus, in some sense, emotions support mind reading. People use expressions, but they use it in context. And machines can potentially recognize and enact this function. Now, there's some complications in doing this kind of work. One is if you're using automatic techniques, typically you'll take an image like this from a video, run it through a recognizer, and you'll get something out like, oh, this is positive, or this is a smile, or maybe if you're lucky, you'll get some facial action units. But smiles are actually pretty complicated. So this is actually the same person smiling in different contexts and playing various economic games. I don't know if you can tell, there seems to be a difference between the cluster here on the right or the left from your impression. Yeah, so these are actually automatically derived by looking at the facial motion, but the cluster on the right is interpreted as being more authentic facial expression. In fact, she's generating these after screwing someone over in a prisoner's dilemma game, And when you see an authentic smile after being screwed over, that's actually much worse for your opponent. So cover it up a little bit. Okay, so the other thing is that emotions can be strategic. So talk about people appraise events, they potentially show these expressions on their face. Observers are looking at these expressions and trying to make some sense of what the goals would have been from that person to produce that expression. But of course, people know this, and so they can generate fake expressions to change the interpretation you're making of their own mind. And this can be pro-social, so we can be polite. A lot of politeness is really showing a different expression that you feel to somebody in order to repair or maintain a social relationship. But they can also be used to sell more expensive cars, for example. And so, for example, this robot is really devious and smart. Rather than smiling after stepping on my foot, it should look sad and regretful so it can step on my foot again, right? So we've been exploring how can you have virtual characters take advantage of this kind of process of strategic emotions. This is one example in the context of negotiation. Negotiation, people lying all the time, and they're using emotions strategically to try to get their own way. This is one particular way that people seem to tend to win in negotiations, which is something we call the fixed pie lie. So imagine a human wants apples, and they don't really want pears, and they're trying to negotiate with an agent how to divide up this basket of fruit. And the agent really likes pears, but doesn't care much for apples. Then what the agent should do is say, you know, I really like those apples too, but I'll tell you what, I'm going to be a nice guy. I'll give you the rest of this junk, and we'll call it even. And I'm not happy about it, but I want to be fair. So this is a very effective strategy, sometimes called the bogey tactic, for basically showing false interest, excitement about an issue you really don't care about in order to trade that off and win. And we've been able to show, we've been running these agent competitions. We have some software. We're doing a competition at IJCAI this summer where people are building agents to compete against humans, mechanical Turkers, for money. And we're able to show that agents that use this particular deceptive tactic can earn more money against people, and people actually see this agent as more honest than an agent that was actually honest. Finally, we also tried to see can this is explain behavior of people in negotiations. So we have large data sets of people negotiating with other people. Many of them are unpleasant people.
Or we could take a much more risky chance, go to fucking war.
And then trying to see, can we, by analyzing their behavior, make certain predictions. And what we've been able to show is that when people follow this kind of deceptive strategy, they actually beat their opponents. There's a trend to show that it's the Machiavellian personalities are more likely to do this, but we can also use automated techniques to show that these people are using different pattern of facial expressions, and to some extent we can detect when they're using these deceptive strategies. So just to kind of summarize, I want to emphasize that emotions are fundamentally social. They do social work, but they're not always what you necessarily think they are. So emotions may represent how you're actually appraising things, and people use that information to make inferences about other people's mental state, but they also are fundamentally social tools that we use to achieve social goals. So I'll leave it at that.
I like both. I've not decided. Part of it is I work really closely both with John and Justine, so I drank both Kool-Aids. But what I want to talk about today, is how can computers automatically perceive emotions and social cues? How can we infer, and why? and be able to perceive the distress level. In fact, in this case, you can see the distress. Oh, I see. That's the button. I'm really loud, so usually I don't need a microphone. So, okay. Hey. Yes. Great. So what's interesting to look in these videos is first the patient. Patient is showing distress. How did she show distress? Rocking behaviors. She showed distress through this hand shape, which was really interesting. But on the other side, what was really interesting is to see the psychologist talking about, please tell me, and everything you say stays between us, and building this dome. And then they say, oh, don't worry about them, and pushing them aside. We're talking together. So all of these behaviors are important. When we're talking about building these new technologies, embodied technologies, we want to look at perceiving the user's behavior, but also knowing how to respond to it automatically. And in this, we want to look at the 3V of communication. I think by now you've heard them. Verbal, vocal, visual. This is what humans are using to communicate. And a lot of it is through what the word we say, how we phrase it. But I want to emphasize, I talked a little bit yesterday, pragmatics. Everything I say makes sense because of the social context, the social interaction. So word makes sense in a context, and that's what the pragmatics is about, looking at the nonverbal communication. I talk the 50 Shades of Yeah. I have an example of the 50 Shades of Yeah. And anybody who is in speech and conversation, try to find out who is speaking. He's a really famous professor from Europe. But it is a meeting of him. And he says yeah so often with very different meaning, and that's really interesting.
Yeah. That's perfect. Yeah.
You know who it is?
Yeah.
Yeah, Nick Campbell, exactly. And that's really interesting. It was only 1 hour. A colleague of mine had recorded and find all these, really different meaning, each of that. Yeah. So this is what's called behavior dynamics. The second level, when you look at human communication, is multimodal dynamics. I'm someone who loves to speak with their hands, so that's one aspect that's really important. The third one, which has been emphasized by Justine, is the interpersonal dynamic. And the fourth one, which I believe is really understudied but very important, is the societal or cultural dynamics. At some point, if you're talking to someone, there's a distance that is too close, probably at some point. This is it. And that's an aspect that you have to think even more when you start building robots and that interact in an interaction like this. So I want to introduce, if you want to build technology, here's a small tools for you. It's free. Oh, free. We love free. This is called, the name is OpenFace. This is technology that will automatically sense from your face, head pose, eye gaze, and facial expression from normal video. This kind of technologies, and similar of one exists in audio, are really beautiful enabling tools now moving forward. If you're interested in it, it's blue on blue, so I'm trying to hide it, but you can download OpenFace for free. I'm going to show a live demo in a few minutes of the system. Let's see if it works. But for me, why do I care about intelligent agent and these technology is because of mental health and clinical applications. I believe that these technology will have a huge impact in the coming years. I would see people interacting, their patient interacting with their clinician or with a virtual interviewer, and as they interact, we look at these what's called behavior markers, looking at what changes of behavior, and then give this information back to the clinician to help them with their assessment. These behavior markers can allow you to look at changes. How is that person behaving today versus a week ago versus 2 weeks ago? And maybe compare that with the population.
And I was really lucky to have great collaborators over the last 7 years. And we look at this technology and see what can we see, what can computers see that maybe doctors may not have picked up. And here is 4 take-home messages that we found using this technology, 4 scientific discoveries. The first one was about depressed versus non-depressed. Intuitively, if I say this person is depressed, they probably smile less often than non-depressed people. That was our intuition. It turned out that the number of smiles between depressed and non-depressed was the same, but the difference was the smile dynamic. People who are depressed have shorter smile and less amplitude. That was the first really interesting one. The second one was people with strong trauma, either because of war or some other trauma. People who have strong trauma, we thought that these people will have more negative expression. This is naturally what you will expect for someone who has strong trauma. What was interesting is over the whole population, we were not seeing any of these. But we did men and women separately. What did we see? We saw this crossover interaction. Men with PTSD, more negative emotion. Women with PTSD, less negative emotion. This was a very interesting discovery. Now, why? Maybe because of Los Angeles, our population? I don't know. Botox? No, I don't think so. What it probably is social norm. There's probably a fact of social norm. Men are allowed to express negative emotion. Women are maybe expected to be more positive. This brings us a very interesting research question. This example is probably the most touching and the most challenging is societal behaviors. We see often through their words, choice of words, that people with, I gave you the punchline, the people with societal behaviors, in fact, use more personal pronouns. But what was really interesting is how to determine who is a repeater versus a non-repeater. And the voice was predictive. People with, I apologize for the animation on this, people with tense voice are in fact the non-repeaters. The ones that are the most likely to repeat are the people who have breathy voice. They made their mind. That was really interesting. And the last one is the social aspect. People who are with clinicians often don't behave the same way as if they are by themselves. So if you want to look at schizophrenia, observe them not just when they're there with the clinician, but also when they're by themselves. So I will do a quick demo that everybody tells you never do a live demo. So let's see if good knowledge there. But this is a live demo of OpenFace and Multisense that will pick up automatically the behaviors. And so what you see in real time is analysis of the facial expression, like smiling, frowning. You also have the voice, although the microphone is turned on for today. And you have gaze. You can see me with lasers out of my eyes, really useful. But all of these cues are used in real time to analyze the behavior indicators. Now, right now it's a live demo. In a normal situation, you look at this behavior indicator over a period of time and sense this information. So this is the live demo that did work. So thank you, the god of demos. And so to finalize the last part, just to emphasize the piece, I want to say we want to look at people's behavior in context of the social interaction. And so often when we look at the patient behavior, we can be often as predictive looking at the clinician's behavior. In fact, there's a famous study where people ask clinicians about assessment for suicidal and distress, and their assessment were somehow good but not always good. But if you look at their behaviors, they clearly behave differently. And so there's a change of behavior that's important. And so when you look at these behaviors, you have to look also at the synchrony and asynchrony of people over time. So I will stop at this point and leave the rest for when we have questions. But thank you very much for your attention. Live demo.
Hi, I'm Daniel McDuff. I'm in the Vive group at Microsoft Research, and I'm going to talk about some of the work we're doing on sensing and understanding human affect. And I'll talk about some specific elements of that. And the speakers have already kind of framed this space extremely well in why these signals are important for both social interaction and understanding the emotion of a user. And there are many applications of this that we've kind of thought about over time. There are already commercial applications of some of this technology and understanding people's reactions to marketing and advertising content, computer games that adapt to the voice or the facial expressions of the player. I'm going to talk in particular about some ways we're thinking and working on using this technology for personal assistance in particular. And the way this might be different from some of the other examples is this might be a situation which is a little less social, not necessarily looking at the interaction between two people or a person and agent the whole time, but how an agent can help provide you with information about your behaviors over time to allow you to reflect on them and understand how you can be more productive or efficient in your work and things like that. As I mentioned, this has been framed really well. I think there's a lot of interesting questions about how we can use this information in such a context where we're helping someone to do tasks, to complete their work. Why is emotion important in that setting when we might just want to complete objectives that we have listed for our day? And the reason is, if people are going to want to engage with and trust this agent to help them do these tasks and want to interact with it, then the understanding of emotion and those cues that are present is really important. This was an article from Harvard Business Review earlier this year that still many people who wouldn't necessarily trust technology to help them make important decisions. And one of the reasons for that is potentially because technology doesn't really reflect the intelligence that humans do in terms of responding to and interpreting these emotional and social cues. So we're doing a lot of work with sensing different types of signals. I'll come on to kind of the emphasis on multimodal signals in a minute, but just to highlight how we're measuring different aspects of people's emotional state. We're using the camera to capture facial expressions and physiological signals, and also to capture context of where someone is. The microphone to understand the sentiment of the language that people are using, but also the voice tone and voice prosody. And then we're also working on agents that communicate emotionally with someone. So that might be on your cell phone, that also has context of the activities that you're doing, the places that you are, and things like that. But one particular setting which is nice to study is the workplace, because we have a constrained context where people are trying to complete objectives. They are in that setting for often an extended period for every day. And we can therefore constrain the context and understand how we can help them complete those tasks better by using information about their social cues. So imagine an interface that could help you get into a state of more efficient working by understanding that you're trying to concentrate now, you're trying to focus on a task, and then be able to help you take a break when you look like you've kind of exhausted that mental energy for that period. So you might have been in the session yesterday where Dan Bohos and the Adaptive Systems team presented Psi, which is a multimodal framework for managing audio and visual signals very well in real time. And we're using that system, adding modules for physiological detection from the camera. So using remote PPG, which looks at light reflected from the skin to capture the physiological signals such as heart rate and heart rate variability. And then also using facial action expression coding, speech sentiment and voice prosody, and then also the scene understanding to help get context of the user. And the overall aim of this is to build systems that we can use to log emotional signals over time very efficiently, and then look at how those are impacting people's productivity and the activities they're doing. This is an example of an interface we built a while ago where we were looking at what happened if we gave this information to individuals to reflect on. So they could look back at how the computer predicted their emotional state over time, and then when they drilled down into those predictions, they could look at tasks and other activities and social communications they were having during that time. With that interface, we were able to find that people did benefit from being able to kind of reflect on this information over time. But ultimately, we can build a system that can actually adapt itself to help people maintain more positive emotion over longer periods of time, or get into periods of flow when they're working to be able to be more productive. That could be a really beneficial type of application. But for the purposes of the panel, I just want to raise a few things I think are really important for the affective computing, the field of affective and social computing going forward. So one is this idea of multimodal processing, which LP emphasized in particular, that there are many tools right now for doing analysis of different modalities, and you can get facial coding tools or speech coding tools, but really we need to consider all of this information together, and that expands our space, our dimensionality of features a lot. So it makes it more complex to mine, understand this data, but it's really important, vital for understanding the emotional state of someone. Another is getting longitudinal data. So there are very few examples to date of being able to collect this type of data longitudinally for individuals. And again, I think as humans, most of us will recognize that understanding the cues or the behaviors of someone is hard if you've just met them. But if you've known someone for a while, you start to notice those subtleties and nuances in a particular person's behavior. And that is hard to collect because it requires users to engage with the system over an extended period of time, and it's a lot of data. Another is personalization. So how can we personalize a system and learn how to adapt it in real time, get feedback from the user and build on that. None of these systems will be perfect in the first instance, and a system that can recognize that or adapt, gain information in a real learning sense would be very useful. And the final one is large-scale data. So as LP mentioned, there's differences in the ways that different demographics express emotion, and that can be related to age. In our data, we've seen examples of differences in expression, baseline base rate expression of emotion, people in different ages, of gender, and in culture as well. And so building up these norms to understand what is the baseline for an individual might be is very useful, because then if we want to detect something like depression, we have a sense of what the norm is, and we can look for deviations in those norms. And one way to do this might be to allow researchers to kind of aggregate their data that they've collected in a fashion that doesn't expose personal information to the community, but allows the community to build on these many data sets that are collected by different researchers and across different institutions. So this idea that we could aggregate some of these statistics that we have across populations that have been studied in different contexts and build something that can be shared across many applications and many researchers, because it's going to be very hard for a particular set of researchers, group of researchers, to collect all of the data they need to understand all of these norms and know everything about expression of emotion in every context. And then finally, I just want to be a little provocative at the end. Some of these systems can now sense information that humans can't. So as I mentioned before, we can...
Imagine if when you looked at someone, you could see...
I'm just going to turn the audio off that speak over. We can use a camera, for instance, to sense the emotion, the physiological state of an individual. So using a camera, we can capture heart rate remotely, and an agent could use that to estimate the emotional state of an individual. Now, that's something that humans, when we interact with other humans, don't have access to. So how does that influence how we design an agent? If this agent has access to information that, when we socially communicate, we don't have. I think that raises interesting questions. What if we can design devices that can give humans some of these, access to some of these signals in social communication? We can start to explore how that changes how you design a system. And I have a HoloLens demo here, which is using the remote PPG to estimate the heart rate of an individual and then magnify that so that you can see it when you're talking to or interacting with that individual. So if anyone wants to try that, you're welcome to at the end of the session. So that's what I wanted to say, and you're welcome to come and try the demo at the end. Thank you very much.
Okay, great. Well done, everybody. At this point, I think we'd just like to open it up for some questions and conversation with the audience. If you would, there's a mic runner out there because we are recording this. It's important that you use the mic. Just say your name and what institution you're from before you ask your question, and you could probably want to say who you're asking the question of, unless it's a general one for the whole group.
Hi, Barbara Gross from Harvard. This is all fascinating and really, really important work. I have a question for everybody based on what you've been able to achieve is phenomenal, given where things were even 5 years ago. But just thinking across the range of examples you used, there are many intended good uses of this, but one can see many unintended consequences. And so just thinking back to what I argued yesterday, I'd like to hear how you're thinking about making sure the systems that your methods get into and the systems you and other people design will be used for good and not bad purposes.
Yes.
Where's the ethical
design? Talk about lying agents, maybe I should. Yeah, I mean, that's part of the reason I was really interested in negotiation as a domain is because it has a lot of complicated ethics around it. And I'm actually serving on an IEEE panel on ethics, and I think there's, I'm not going to answer your question, but just to say that there's often a very simplistic view that an agent should never lie. And when you study emotion in social interaction, at some level, you almost couldn't have a social interaction if you're completely emotionally honest. And in fact, you'd be taken advantage of by other people if you're completely emotionally honest. And so part of trying to search for ethical frameworks to think about it in the context of negotiation, of course, I turn to legal ethics, because this is where, this is where they've been the most thinking about negotiation. And oddly, so my agents are compliant with the ethical guidelines for the American Bar Association, which is to say that not a hard bar to cross, but that oddly, well, interestingly, there's a big debate about should a lawyer do certain kinds of what they call misrepresentations on the behalf of their client, and if they are completely honest, hey, my client will settle for $30,000, they're in some sense putting themselves at a conflict of interest between their client and the other's interests. And there's a lot of struggles of how to deal with that. One solution, which they've tried to do, is basically what's called a communitarian methods, where basically what you should do you should publicly advertise your ethical framework. So a lawyer would say, I'm only going to negotiate honestly, and that's my framework, and I'll put myself up to sanctions if you catch me in a lie in some sense. And so I think this is a long answer, but to say that it's not a simple story, but I think you have to fundamentally work with professional ethicists, because the simple answer, you can't just, is not going to work. And so I think you really have to partner and incorporate into teaching in our field how to reason with and grapple with these ethical questions, because they're not simple. So that's not an answer, but just to say, share what you were saying yesterday, that it's not simple. Yeah, sorry.
Yeah. To follow on from what John said, the answer isn't simple, and I think the bottom-up aspect of it that he said last is what I would agree with. So I've been talking at Davos for a bunch of years now, and the world leaders always want to regulate. And there's an endless talk about how to regulate these technologies. We have to stop AI. Only a certain amount should get through. And I've been arguing that this top-down response is short-sighted and that the bottom-up response is much better, and that is education. And that's clear from what you've been doing in your classes, that in every artificial intelligence class, we also have to include the ethics of what we do. And I believe that very strongly. But within your question is packed a whole bunch of other questions. So one thing that I've been thinking about a lot is how to build systems that don't replace people because they depend on people for their operation. So I build systems that are fundamentally interdependent. They can't exist unless there's a person. People worry about the systems that we build destroying our notion of sociality and destroying the community that we live in. And I work very hard to build systems that preserve the things we care about most, such as social interaction and connection. So there's lots of different kinds of ethics. And I think expressing to our students what we care about when we build the systems we build, and thinking about how to convey the dilemmas, not the simple answers, is really the way to deal with it.
Yeah, I think both of those answers are excellent. And I think having systems that can explain and must explain why they came to these decisions is really important. For example, you could have a system which is helping you complete a task, but it has missing information and therefore makes the wrong decision, or is built upon large-scale aggregated data, and some of these models are very complex. If they can't if you can't introspect them and they can't give you justifications for the decisions, especially in some of the clinical applications, then that's dangerous, I would say. So I think there's a real need for this across many aspects of AI, but I think it's really interesting how we design agents that are socially or emotionally aware that can kind of explain what types of signals they were using to make decisions or to influence their behavior.
And I will just add, because I agree completely about this aspect of assistive technologies or technologies with a human in the loop. That's very important, and that's why I'm a little bit worried to have this idea of a cell phone that tells me if I'm depressed or not without any human or expert in the loop. That is not how we build these technologies. That's not how we thought about this. But the other thing is ownership of the data. You should own your own data. And that is true, or that should be true at least in the internet, although that's a different debate, but even more when it comes down to anything related to your health. So you should own the data and decide to share it with your doctor or clinician. That should not be, that is a challenge in how we build the technology so that it is clear what the data is, so there is a transparency that's needed. And who wears it and how can I share it and how can I review it. And so that brings a lot of interesting HCI, UI question on how visualizing the data, but also how to make it transparent from a machine learning. And that's why explainable AI is so important, is you want to know what's happening in the bit. So I think this is a part of the answer. That's a really good question.
Just to emphasize the importance of your comment is that sometimes these ethical problems are seen as down the road, but this is now, right? So people will disclose more intimate information about themselves, including financial records, to an agent than they will to a person. One of these people will be manipulated and not recognize these characters. People will engage in social action with these characters and then be less inclined to engage in social interactions with other people. So this is all with current technologies, an incredibly important question.
Hello. So this is, I'm here. I'm Pablo Paredes from Stanford University. So thank you so much for all this very important work. So my question is around, so we have all these sensing capabilities and a lot of good things to understand what's going on, but there's this whole world of interventions and the design of the right type of interventions to actually overcome some of these problems, which is not a natural extension of sensing, right? Not just because you have a sensor, you don't just have the right intervention. As a matter of fact, I would say that sometimes it's misleading to actually create an intervention that only uses the sensor data. I would like to hear more about how do we use AI for recommending to deliver the right interventions. I think what we need is to actually help people find the right ways to do things, not just to know what's going on. And how do we do that? Because I think it's not a trivial question it's not just an ethical problem, it's also a problem of, like, it's not traditional UI to design something that you don't want to do. An intervention sometimes has to make you change, and that's not a trivial problem. So if you can extend and expand on what you've seen as your technology, how do we use AI to really intervene correctly? I think that's a very important problem that we're not doing enough research, I would say, as a community.
Maybe I will start. This is a very good question. I believe this is, it will be a multi-stage process to solve and to bring AI and interventions together. I believe that there's a short-term milestones that is specifically in mental health. When you do these interventions, they're often based on documenting the behaviors of the patient. And looking at changes. Changes are key to that. For example, in many cases, you will do mental state exam, MSE, which has 48 different points that the clinician will have to go through to decide how is the current state of the patient so that I can decide what is the right intervention moving forward. There's some of these points that humans are very good and intuitive about how to infer them, but there's some of them computers can do even better. How quickly someone speaks, something about the change of voice, something about the behavior changes. This is something computers can do very well. And so I think in the short term, yes, we are going to include where technology can help and sensing can help. We'll add this because humans can have biases because they are using the other symptoms and focusing on other symptoms such as sleep or some other maybe gender or some other demographic. They may forget to look at these changes of voice or behaviors. So I think that as a short term, this is where we want to go. Now, the next stage is continuing this dialogue between clinicians and AI researchers on the intervention. But I think there's places in the short term we can already help for that.
I think part of your question is not just about intervention, but inference. So sensors give us data, but to turn that into knowledge means inferring what those data mean. So I did not agree with John's description of the smile early on in his talk because he seemed to assume that it was a particular emotion. But as he showed later in the talk, there are different kinds of smiles. And even the same kind of smile can mean different things on someone of a different gender or someone of a different culture or any one of us in a different context. So in our data, we find smiles most often after someone says something that violates social norms, after they're rude. And our inference about those smiles is that it acts to mitigate the face-threatening impact of that move. That is to say, I wish you well, even though I've just insulted you. We smile. And we know that because we've looked at these temporal association algorithms that tell us that when there's a violation of social norms, like an insult, followed by another violation of social norms by the other person, and then one of the people smiles, rapport goes up. If there's not a smile, the rapport goes down. And so we intuitively perhaps know what these things mean, but we need to build those inferences into our algorithms. And LP's point about people having biases, as we know, so do algorithms, because algorithms are built by people who have biases. And we find those same exact biases about gender and about ethnicity and race, for example, as notorious examples of that kind of bias. So when you ask about what the correct intervention is, I think the question that comes before that is, how do we build the inference engine that makes sense of sensor data?
Yeah, and to add to that, I think, perhaps the simplest intervention is allowing an individual to see their data, right, and then and see how it helps them reflect on that. So that's one step. When we get into more complex interventions, it's obviously domain specific, and it's been very hard up until this point, I think, for someone who's an expert in building interventions to build a system that uses artificial intelligence or machine learning to predict when to give that intervention or what intervention to give, because it's inherently multidisciplinary. It requires a lot of knowledge across domains. And so I think now with the tools like the tools that LP is building, OpenFace and things like that, some of these systems are now much easier to use by someone who's a practitioner in psychology or psychiatry. And so I think we'll start to see more exploration in that space. Mary has done a lot in our group already, and I think one of the things that we really need to emphasize is that in all these situations, people need control and to understand what the system is doing. Because as soon as we start prescribing things based on an algorithm, it's going to get it wrong some of the time. It's a very complex thing, and that can frustrate people. And so we need to be able to handle that. But perhaps one of the entry points is understanding for a simple intervention, when is the time to give that intervention? That might be one of the sort of simplest things that you could approach as a problem in terms of understanding when is a good time to interrupt someone to help deliver something that might help them.
Just to give a very specific answer to your question. So, I mean, what the speakers are pointing out, there's a lot of challenges in creating this kind of closed loop, which is really the dream, to have the system sense, understand, and respond. And the only area that I've found there's some success in creating this kind of closed loop systems is in some work in automated tutoring systems. So people like Sidney DeMello, who are trying to detect student frustration and boredom and automatically adjust interventions, basically teaching interventions to keep them kind of in the kind of optimal zone of learning. But it's a very fraught and hard challenge.
I'm Monojit from Microsoft Research India. And this is a question more for Justin and John, especially on the rapport building part and the negotiation game. But I'll pose it as a more general question, which is the basic philosophy seems to be that we look at human-human interaction and from that learn how people build rapport or negotiate. And then take those findings and try to build agents which will kind of mimic that, and we'll get better results. And your experiments show that it does do better. But the fact that the human knows that it's interacting with an AI agent instead of another human might change the behavior of the human. I'm sure it does to some level. So how much do we understand that how much of this knowledge is of human-human interaction can be used or applied in the context of human-agent interaction? And the related question is, it also people learn how to interact when they are in a new environment. So I presume they will also adapt to the way the agent behaves over time. And kids who grow up with a certain kind of technology could behave very differently than somebody who adopted it when they are 50 years old. So any comments on that?
So I've spent in the 24 years that I've been building virtual humans, I've spent a lot of time trying to focus on the unconscious behaviors that we use. So with other people, we have different kinds of nods that the other person will pick up to mean different things, and yet we're entirely unaware that we're doing it. We use our eyes to signal that we understand or don't understand. We actually look at other people when we don't understand, not when we do understand. We don't nod. We may nod in both cases, but it's the looking at the other person and pausing that lets them know that they need to clarify. And by focusing on those, I'm trying to get away from ways in which we intentionally act differently towards agents and go towards these little micro behaviors that we use with other people and that we can then use as a metric of success with agents. So I've compared human-human interaction to human-agent interaction to see whether those same tiny unconscious behaviors are used, and if so, I believe that we've built an agent that is sufficient to elicit natural behavior from the human. That doesn't mean there's not going to be a difference. As John said, it's the stranger on the train phenomenon with an agent. So for reasons that we don't entirely understand, people disclose more to agents than they do to other people. There's something called the persona effect, where if we believe that an agent is controlled by a person, we behave differently than if we believe that the agent is autonomous. And those are things that we have to test. So I talked about the human-human being translated into human-agent, but the evaluation evaluates human-agent and then compares it to human-human so that we know what changes we're seeing in the human-agent context and then can adapt for that. That's a kind of a technical step-by-step explanation.
And just
but-
so there's been an enormous amount of work initiated by Cliff Nass at Stanford trying to look at how does that variable of whether you think as a person behind here or whether this is a machine change the nature of the interaction. And Cliff emphasized that people often treat machines like people and follow these social rules, but more subsequent research has emphasized there are very big differences. And particularly those differences, if the machine doesn't enact the functions that these signals, so you can smile and, or say I'm sorry, but the 10th time your computer program tells you it's sorry for crashing, it doesn't kind of work anymore. So you have to have the function for the behavior to persist. But the other thing is, I think, if I had given a different talk, sometimes I would talk about why there's too much emphasis in this field on copying people. In that, for instance, it's easy because you get data on people and you can make them up. But I think the more interesting thing is to make models that are complementary, different, better than people. And so an example is the interview agent that LP presented, where really, if you look at the disclosure, the research on how do you get people disclosed, there's two pathways to getting people to talk about intimate things about themselves. One is, do you build rapport and you feel comfortable and you draw people out. The other is you emphasize anonymity and non-judgment. So computers don't judge you. And so what we find is that people, when they talk to this agent, on the one hand, the rapport helps draw them out, but on the other hand, they report less fear of negative evaluation. They do less impression management. They show more honesty in their both expressions and behavior. And so it seems like we're creating something in some senses better than a person or a computer. And so I think we need more of research on trying to understand how to create something that's not using humans as the guide.
Or a combination of the two,
Yeah.
that looks at human behavior and draws from it the best of those behaviors, the most evocative of the intervention that you're trying to build.
I had a question about, I was curious about the sort of metric space of emotions and what's known about that. So first, in a sort of observation, an analogy, like sort of the human face, right, in graphics or for modeling it from an anatomical perspective, we have like a very detailed understanding of the dimensionality of that, muscles, the amplitude of motion, things like that. So the geometry of the face we understand. Now obviously emotions are more abstract, not really a geometrical, like in the real world kind of a thing. I was just wondering, all the comments you have about smiles mean different things, nods mean different things. How much is known about dissecting that into what the total geometric metric space of emotions is? How far are we towards a total description of it, its dimensionality and its amplitude?
You're touching on enormous theoretical battles in emotion research. So there have been long-standing disagreements that have not been settled as to what is emotion, or does even emotion exist. So there's dimensional theorists that argue that you can only characterize, regardless of the modality, an expression in terms of valence and arousal, maybe dominance. There's others like Paul Ekman that argue that there's basic emotions and you can tie them to circuits in the brain that coordinate various activities. To others that say basically emotion is a cognitive construct that we basically introspect on ourselves in the context we're in, and we invent a word in our head that represents that expression. And so there's not a simple answer, but unfortunately it has profound consequences for training machine learning algorithms because you need a label, right? And so in my own work, what I found most useful is to not use basic emotion labels or valence, but try to tie recognition to more primitive motor patterns like action units, and then try to use action units directly to make inferences about mental state and behavior. But that's one of many approaches.
I would say to add to that, in the field of facial analysis in particular, the facial action coding system is a taxonomy which is intended to be objective and allow coding of behavior on the face, which can then be used to map to some of these labels that we can come up with related to emotion. In other modalities, it's harder. So speech, there's not the same objective form of coding of voice tone, for instance. And then that means it's somewhat harder to be able to explain in language what's happening. Not saying that an algorithm can't map features to labels, but it's that level of systematic analysis and explainability that's kind of helpful. That's an example, but it doesn't address the larger question of what is an emotion and what is the space of emotions, which is still hotly debated, and there's no one system that generalizes.
One really interesting experiment that a student of mine had done is have one person telling a story, and have many people listening to it, all believing that they are the only listener. You can do that through Skype. And that was beautiful because you had one stimuli and many people reacting to that same stimuli. And then you can start looking at nods and smile and see maybe the function is the same, but it really expressed differently. And that emphasized the point which sounds so obvious now that I will say it, but there is a lot of personalization or individualization or idiosyncrasy in this, because we had the dream of like having a taxonomy of nods. I spent 3 years of my life on nods, so I know too much thing about nods. But that there will be a small nods, like a continuation and nods. You have an acknowledgement nods, you will have an agreement nod, and it will be higher and lower. But it turned out that people are very broad in their range of it. That's the obvious one. And anybody doing speech sounds like, hey, this is obvious. There is a range for the voice. But it's not just a range. There is also some people. There's one person who did nod like this. And you don't expect that. But this was clearly an acknowledgement nod. So I believe that as people, what computers need is better adaptation to individual. And I think that's one of the way to work is, yes, you have this generic model of nods and smile, but individual, and we do it as human very much, and that's the way to move forward. I thought that was good.
I think we might have time for one more question. It's all been great.
There's someone with the microphone.
There's one over there.
Hi.
Oh.
I have the microphone. Sorry. I guess I had two questions, unfortunately, so maybe we'll choose one. But one of my questions was, we keep talking about the self-awareness and reflection of these agents, and the complexity with these agents learning from a group of people. How, with these kind of black box algorithms, do you see to put this introspection or self-reflection of these agents in? But my other question was more on the value of making agents more idiosyncratic, and how that plays in like the longevity of this personality that an agent might have, and what's the value in that versus more of like a collective agent?
Hard questions.
Do you want to start?
To answer the question about explainability, I think there's a lot of work in this space right now. The affective computing community is quite closely tied to the machine learning community, and there's a lot of things we can learn from research in machine learning about how to build models that are explainable, and I think those should be applied. Can I come back to the previous point, is that there's some taxonomies we have which are understandable to humans, are somewhat objective, and so ways that we can break things down in terms of those taxonomies, whether it's facial patterns or when we get into other modalities, it's much harder. So what does an increase in heart rate mean? What does your breathing was faster? We can understand what that means in some senses, but not necessarily why it happened, and so it's very complex to ask a machine to explain all of these relationships, but at the very least it should be able to identify those markers those features that were used and those features should be something that humans can kind of somewhat interpret or understand. But it's hard because a lot of these things about voice tone and physiology, we have this sort of tacit knowledge about how they relate to emotions, but it's not defined. We don't. It's not something that we actively think about a lot of the time. So that it's in some ways even more challenging than building an algorithm that can explain itself when it's doing sort of image recognition and things like that, because we don't always have the language to do it ourselves.
To speak to your comment on idiosyncrasy, I mean, I don't have a scientific answer to that question, but I think one interesting place to look is where people consume the most emotions, which is probably cinema, and to look at how emotion is thought of and conveyed in that realm. So I recently had a discussion with a director from the Emoji Movie, because I thought that'd be an interesting way to get insight into emotion. And it's fascinating to see how, I mean, when they think of emotion, it's never like a basic emotion. It's always about mixtures and contrasts and how regulation and how to convey the complexity of emotion in human life, but in a very stylized way that's very easily communicated. And so I think there's actually a lot of insight from the arts to address why we want this kind of interestingness and change and complexity. But that's not really a great answer, but that's one place to look.
All right, I think we are out of time. Let's give the panelists another round of applause.